All right, let's go through some examples from section 1.5, which is basically different types of equations. This first one is a rational equation, right, because it's got a bunch of fractions. And anytime we have fractions in any type of equation, whether it's just a fraction with a number or a fraction with variables, it doesn't matter. The rules are still the same. We want to get rid of fractions because we want to be able to reset this question to something that's a lot easier. And the only way to get rid of fractions is to multiply by the bottoms of them. So I say always pick the largest one, and we're going to multiply everything through by 3x plus 3. So we're going to have 3x plus 3, right, times 3 over x plus 1 minus 3x plus 3 over 2 equals 1, because those just cancel. Now you always want to take a look and see if something else might reduce. And of course it does, because 3x plus 3, right, is really 3 times x plus 1. And now the x plus 1's will cancel, and all that's left is the 3 times 3. So this becomes 9 minus 3x plus 3 over 2 equals 1. Now, if you want to, you can combine things, whenever you want, but you still have to get rid of this fraction. So you might as well just multiply everything through by 2 and get 18 minus 3x minus 3. Don't forget that you're subtracting each piece, right? So when you get rid of the fraction, you're still subtracting this whole thing as one piece. So you're subtracting each individual piece. And then, of course, you have to multiply everything by 2. So that gets 2 as well. Now, combine everything, right? 18 minus 3 is 15 minus 3x equals 2. Then I would move the 3x over here. 15 equals 2 plus 3x. Move the 2 over here. 13 equals 3x. Divide both sides by 3. And there you have it. 13 thirds is x. All right, that's our first example. Let's look at another one. Okay, here's a second example. And again, we've got fractions, so multiply by the bottoms. So 10 times x minus 3 over x minus 12, right? Plus 4 times x minus 3 equals 0. Now, you might want to clean this up, make it 4x minus 12. And this doesn't change, right? We haven't done anything here yet. All right, you also might want to clean this up. You don't have to do everything in the same order every time. You know you have to get rid of that fraction eventually. Do it whenever you're comfortable with it. But if you see some easy stuff you want to do now, that's fine. The 12 and the 12, right? They're both negative. And then plus 4x. And then, of course, this still equals 0. All right. So now we've basically done everything we can at this point. We still have to get rid of that fraction. So multiply everything through by x to get rid of this last fraction. And you have 10 times x minus 3 minus 24x plus 4x squared equals 0. And now we've reset the question. And now it's a lot easier because we don't have any fractions. So let's take the next step, which is to get rid of grouping objects. So go ahead and distribute. All right, and then everything else is still the same. And then we can now put together like terms. So we've got an x here and an x here. So 4x squared minus 14x minus 30 equals 0. Everything's divisible by 2. But that's it. Doesn't reduce any further. So at this point, we have to go ahead and try factoring. And if that doesn't work, we're going to have to go ahead and try the quadratic formula. So we have to do 2x and x because that's the only way to get 2x squared. And now we're looking for factors of 15. So if we do 5, this will give me 5 times 2 is 10, and 3, and the difference will give me 7, which is perfect, right? So 5 and 3. And I need negative 7, so I need negative 10 plus 3. So this gives me an answer of 5, right? Because you set each of them equal to 0. And when you do 2x plus 3 equal to 0, you get 2x equals negative 3, x equals negative 3 halves. Now something that I should have mentioned on the previous example is you always want to go back and double check your answer, plug it in and make sure it works. And that's especially true when you have multiple solutions, right? We've got two solutions here, and there's a chance that only one of them is correct. So you want to plug them both back in and make sure they work. And really, especially with fractions, what you're looking for is to make sure that none of those fractions end up being 0 on the bottom, right? Because you can't divide by 0. So for instance, if one of our answers was 3, that would be a problem because then up here, right, we would have 3 minus 3, which was 0. Or if one of our answers was 0, it would be a problem here. But neither of those are an issue, but you should still just plug them in to check your work and make sure you get the right answer. All right, let's look at another. All right, here's an equation that involves a different type of grouping object. It involves square roots. And I say it's a grouping object because it has both a variable and a constant that are grouped together inside it, right? So there's no way to solve for x because right now x is being grouped together with this 1. So we can't isolate x and get x all by itself. So that's what I mean when I say get rid of grouping objects. And the only way to get rid of this type of grouping object is to square both sides of the equation. But you have to remember, when you square both sides of the equation, you have to square both entire sides of the equation. So everything on the left gets squared and everything on the right gets squared as one piece. You're squaring the left as one big piece and the right as one big piece. So what I mean is you're squaring this all together and then you're squaring this all together. So in order to get rid of square roots, the first thing you have to do is isolate one of them. And this one already was isolated for us. And what I mean by isolate, obviously, is get one on one side of the equality with nothing else there. And then there's another one over here with the 2, but we can't do anything about it, right? They're both there. Okay, if I square both sides, left-hand side is easy because when you square a square root, it just goes away, right? You get what is inside the square root. When you square the right-hand side, what you're really getting is this thing times itself. So you have to remember that you don't just square the 2 and square the square root. You have to FOIL this thing out and you get those middle pieces, right? So you get 2 times 2, and then you get 2 times that radical, then you get the radical times 2, and then you get the radical times the radical, and you put all that stuff together, right? So you get 2 times 2 is 4, plus 2 times the square root. Sorry, that should be a plus this one times 2 gives me another 2 times the square root. And then finally, that one times that one gives me just that stuff, because the square root's in the square root, it undoes the square root, you get whatever's left over. Now you can put all the stuff together. So this is 4 plus 4 times root x plus 1, and then of course plus x plus 1. And of course you can put that together even further and make it 5, right? Plus x plus 4 times x plus 1. Okay, and then on the left-hand side, we still have 3x plus 1. All right, well, we still have a radical, so we have to isolate it, get it all by itself. So that means move the 5 over, move the x over. So subtract 5, subtract x. When I subtract x, I get 2x. When I subtract the 5, I get negative 4. And then I still have 4 times radical x plus 1 on this side. So I've isolated it. It's still being multiplied by a constant, which is totally fine. This whole equation, everything's divisible by 2. So if I wanted to, I could divide by that. X minus 2 equals 2 root x plus 1. That's a legal move. That's okay. And that makes it a little bit simpler, right? Because our goal is to just always make it simpler. Okay, now all that's left to do is square it again. Square both sides. Well, on the right-hand side, it's pretty easy. We get 4 times x plus 1. Why is it 4? Because you got to square the whole darn thing. So 2 of these times 2 of these, you get 4 of these squared. And when you square them, the square root goes away. So you end up getting 4x plus 4. Okay? On the left-hand side, again, we have something times itself, so you have to FOIL it out. Or if you remember the pattern, when you have a minus b squared, you get a squared minus 2 times their product plus b squared. So I get x squared minus 4x plus 4. Now, if you don't know that, you don't have that memorized, then just FOIL it out. I'm not going to waste time doing another example of this. Do it yourself if you don't remember what that is. All right, so x squared minus 4x plus 4 equals all of this stuff. Now, how do we solve it, right? We've gotten rid of all of our grouping objects, so we've reset the question to something pretty basic, and all we have to do now is solve whatever's left, and what is left is a quadratic. So to solve a quadratic, we have to get everything on one side and set it equal to 0. So you have to subtract the 4x over to that side, and you get x squared minus 8x. Then you subtract the 4 over, and it cancels that 4. So it really isn't a quadratic anymore because we don't have that constant term. So it makes it a lot easier because now all you can do is factor out an x, right? You factor out the largest thing they both have in common, which in this case is an x. So x times x minus 8 equals 0, which means x equals 0 or x equals 8. Now, anytime you square both sides of an equation, you have created a second answer. And that second answer might not actually be okay with the original equation. So you have to go back and check them. And in fact, if you plug the 0 back in, it doesn't work because you get, right, 0 plus 1. So this becomes 1, and the square root of 1 is 1. When you plug a 0 in here, this is 1. The square root of 1 is 1. And you get 2 plus 1 is 3, so you get 1 equals 3, and that doesn't work. So the 0 ends up not being a solution, but the 8 does work. Okay, so the answer for that one is 8. One last example for this chapter. All right, this one is a word problem. They give us this equation, which is supposed to model the population of something. I think it was fish in a pond. And then they said they wanted us to figure out how long it takes until the population is 500. Well, if the population is 500, that just means P is 500. So now we have this, and they want us to solve. Well, I tried to show students how to do this in class by showing them that this was a quadratic function in disguise because you have a variable here and its square here, and that is in fact a quadratic. You could move the 500 over, set it equal to 0, and solve it with substitution as a quadratic. But that made a lot of heads spin, and I realized that was probably a stupid thing to do. I should have showed you the easier way, which is just treat it like a normal equation. We've seen, in the previous example, if it's got square roots in it, what do we got to do? We got to isolate the square root and then square both sides. So we're going to do the same thing here. We're going to isolate the square root and square both sides. So move everything over to the left, get this 10 square root of t all by itself, and then we're going to square both sides. So we subtract the 140 over here, which gives us 360, minus 3t equals 10 root t. Now, we can't divide by a constant because they're not all divisible by the same thing, right? This 3 here is stymieing us. If it was a 30, we could divide everything by 10 and our life would be awesome, but we can't, so we square both sides. And remember, when you square both sides, you square them as one big old piece, so you're going to have to FOIL out the left. So on the left-hand side, you're going to get 360 squared, right, whatever that is, and then minus 360 times 3t twice, right? You're going to get two of those, minus 360 times 3t. And then, of course, you're going to get minus 3t times minus 3t, which becomes plus 9t squared. And on the right-hand side, when you square that, you get 100t. All right, so now you're going to have to crack out your calculator and do some of these big numbers. So you get this big old number, 129,600, that's 360 squared. And then here's 2160t, that's just this number, right? Plus that number, that's how many total t's you have. And of course, we already have the 9t squared and the 100t. And you recognize, oh, hey, this is a quadratic. To solve a quadratic, got to set it equal to 0, so I got to move the 100 over here, right? And so now we've got 129,600 minus, this is another 100, so 2260t plus 9t squared equals 0. Okay, now you're hoping to reduce this before you try and do it because this 9 is a bit of a bear to work with in a quadratic. But the only way to do it would be if we could divide everything by 3. So is this number divisible by 3? So if you add up the digits, you get 10, 12, 18, that one's good. But this, when you add up the digits, you get 10, and 10 is not divisible by 3. So this one isn't divisible by 3. So we cannot reduce it at all. So at this point, you're going to have to do the quadratic formula, which really sucks, right? Because these are big numbers. All right, when you plug the numbers into the quadratic formula, it looks like that. And then again, stick it in your calculator to do the work. All right, so you plug everything in, do the math, and you're going to get two solutions. This 665 is not accurate. I rounded, right? This doesn't come out to a perfect square. And when you do the plus and minus, you're going to get two different answers. And the smaller one is the first answer, is the correct answer, right? Because they want to know how long it takes till it happens. So they want the first time, not the second time. Or there might be a math mistake in here. There should really only be one solution. So one of these shouldn't work. But you get the idea, right? Is you treat it like anything else. Isolate the radical, square both sides, and then go from there. It's just this one gets, unfortunately, some unruly numbers. Okay, that's the techniques you needed for 1.5.